In this lesson, we're going to continue with exponentials and logarithms A, and today we're going to look at transformations of logarithmic graphs. Now, we've already done a lot of graph transformations in the course, so hopefully this is not something completely new to you. So we know that given any graph f of x, for example, we can reflect, move or scale it, and each transformation influences the points that we know on the graph. And in order to keep track of these influences, it's good to use a table. Now, the same rules apply for transforming logarithmic graphs as we have previously studied in the functions and graphs topic, and the same rules that we used for transforming exponential graphs earlier in this topic as well. So, like I said, when we did it in functions and graphs topic and when we transformed exponential graphs, we kept track of our points using a table, so we're going to do the same thing here. So hopefully it will be familiar to you. Now, these were all the various graph transformations that we could have. You can see that the first 5 here influence the y ordinates and the last 5 influence the x ordinates. Okay. So we'll go on with an example here. So we want to sketch the graph of y equals log to the base 5 of x minus 3. So we can see firstly, before any transformation took place, that we had the graph of y equals log to the base 5 of x. So we would start with that. And we know that 2 points on the graph of y equals log to the base 5 of x are 1, 0 and 5, 1. So you can see those there, pointed them out here, and I've recorded those in my table here. And the transformation that's going to happen is we're going to be drawing the graph of y equals log to the base 5 of x minus 3. And we know that that's going to be a horizontal shift of the graph to the right by 3 units. So as a result, we need to add 3 units onto each of our x ordinates. So the point 1, 0 will transform and become 4, 0, and 5, 1 will become 8, 1. And then we can go ahead and we can plot those points, 4, 0 and 8, 1. And that allows us to then sketch our curve. And that is the curve of y equals log to the base 5 of x minus 3. So just now would be a good time to pause the video and copy this down into your notes before coming back for the second example. Okay folks, welcome back. So we'll have a wee look at example 2, and this time we want to sketch the graph of y equals log to the base 5 of 2x plus 4. So you can see that we've got 2 transformations happening here. We've got a 2x instead of an x here, and then we've got this plus 4 at the end. So as always, we'll start off with our basic log graph, and we're working in base 5 at the moment. So we've got y equals log to the base 5 of x, and 2 points which occur on that curve are 1, 0 and 5, 1, as you can see from the graph. Now the first transformation we are going to look at will be y equals log to the base 5 of 2x, and then we will look at what happens when we add 4 to that. So this first transformation, changing from just the x into the 2x, and that results in a horizontal compression. So that means that we are halving all of our x ordinates. So we're dividing all of our x ordinates by 2. So we get a half 0, and our second point will be 2.5, 1, which is 5 over 2, 1. And at that stage, we could sketch our graph of y equals log to the base 5 of 2x using those 2 points. So you can see that that horizontal compression has happened. And then we can look at the last transformation. We have to add 4 onto all of our y ordinates, and that will result in a vertical shift 4 units upwards. So our half 0 will become a half 4, and our 5 halves 1 will become 5 halves 5. And then we can go and plot those points and sketch the new curve. And you can see that that horizontal shift has happened. The graph has moved up by 4 units. So just now would be a good time to pause the video before the screen goes blank and take this down in your notes before trying some of these examples in your jotter.